Hello folks, and welcome back to the next episode of my tutorial series. This episode is going to be covering binary values and what they mean. So basically, binary values, converting them to decimal values, hexadecimal values, etc. So if you already have like a pretty good background in this kind of thing, feel free to skip to the next video. That's basically what I'm going to be covering today, and it probably won't have that much of a survival implication, besides sending analog values long distances. All right, so let's go ahead and hop in. So basically, when I say binary value, I'm talking about base 2. Our current number system, the number system we use every day, is decimal, which means it's base 10, which means we have 0 through 9. In binary, you only have a 0 denoted by an off and a 1 denoted by an on. And using that, we can make up basically any number we want. So think of it like counting to 10. In decimal, you'd count to 10 by going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that 10 is all you're doing is just putting the lowest non-zero value in your system in front of your current number, and then putting that current number to 0. So 9 goes to 1, 0. In this case, all we have is 0 and 1. So we're going to count 0, 1, and then it flips just like going to 10. So then we go 1, 0, and then 1, 1, and then 1, 0, 0, on and on and on like that. That's a little bit confusing. So I have this little demonstration set up. You can also think of it in another way, which is like this. So each lever kind of represents a value. So this lever represents 1, or whatever, lamp. This lamp represents 1, this is 2, this is 4, and this is 8. When the lamp is on, you take whatever value it is and add it to the total. So let's say this one and this one is on. You take 1 plus 4, and this value would represent the decimal number 5, the decimal equivalent 5. Let's turn on these three. This would be 8 plus 2 plus 1, and that would represent 11. So you'll notice maybe with 4 lamps, we can represent 16 unique numbers. And that would be 0, which is what we have right now, all the way up to 8 plus 4 plus 2 plus 1, which is 15. So 1 through 15, add a 0 in there, and then you have 16 unique values. Which is kind of convenient, because this guy right here, well, not really that guy, but this guy right here, you know, he has 15 on signals and 1 off signal. So 1 through 15, add a 0 in there, and you have the exact number of values that you can represent with four levers. Yeah. So we're going to be using that kind of idea here in a second. So I'm probably not the best person to explain this kind of stuff to you, but I'm just kind of attempting. If you're not getting this, just go ahead and look up a video on binary numbers and what they mean. I'm sure there's going to be like a nice infographic way of showing this. All right, so let's take a look at something using this. All right, what I have built here is something that I would call a digital to analog converter. What it does is it uses those same 4 levers that we saw earlier to produce a redstone signal value from 0 to 15. As shown over here. So let's go ahead and throw a 1 and a 4. So it's 0, 1, 0, 1. And that's going to be 5, a signal value of 5. Throw in a 2 there, 7. Throw in the final bit, and that's 15. So the math behind it, now that we have something that we can play with, it really isn't too bad. It's not too daunting. Simple addition. You'll also notice that I have A, B, C, D, E, F below anything that's 2 digits. That's standard hexadecimal notation. So in hexadecimal, you have digits 1 through F. And A is basically equivalent to 10, B is equivalent to 11, etc., etc. And this way, you can denote the value of a comparator with just one digit, or one character, instead of having to use two. That's all that is. So 10 is equivalent to A, 11 equivalent to B, etc., etc. Alright, so let's take a look at the redstone behind this really quickly. I'll go in depth later. So as you can see, it's pretty small footprint. I would say this is very easily survival friendly. Realistically, it's not too bad. So what would this be used for in a survival setting? The biggest part that I would have to say would be very precise controlling of analog values for things like timers, timer systems, or possibly transferring analog signals a very long distance. So let's say you have an analog signal on that side of the map, and you want to get it over to that side of the map. Are you going to run just a huge line of comparators? Well, that's going to increase lag, that's going to increase delay time. It's just probably not that great of an idea. So what you could do instead is build an analog to digital converter over there, run 4 wires all the way over to there, and use repeaters instead of comparators. Oh, and at that end over there, you'd have one of these guys, an analog or a digital to analog converter. And there you go. You have analog signal over here, analog signal over there, and they're connected. And it would be a little bit more convenient, maybe, depending on your situation, than having to run analog values. Another situation where that might be useful is if you're traveling a very large z distance, because you can easily push digital values up, but analog values are a little bit more tricky to push upwards. So that's how you might use this. All right, so let's take a look at trying to make that digital to analog converter. So basically the idea is we're going to take signals from each one of these levers and use them to add signals, add constant signals together to form our one signal. And those constant signals are going to be 1, 2, 4, and 8. We're going to get those constant signals from furnaces. So basically, we're going to need to start off with an adder, right? Just a simple adder. And so this is a subtraction chain like I was talking about in last episode, and then we invert that. And that's how you do addition. Okay, so we're going to need to put our values into that. I forgot to do this. We're going to need to put our values into there. And now we're going to need to line these up with our values. So to do that, this is how I managed to route it. I kind of staggered a little bit. Furnace goes here, like this. And this realistically at this point, you should be able to understand why I'm doing, or like the concept behind it. But it's really all routing at this point. So furnace number 1, the one with just a value of 1, I will go here, and we'll just go ahead and route that directly into the line. There we go. Our second furnace value is going to be coming from here, and I'm going to route it up like this. Notice I haven't inverted it yet. I'm going to invert it now, and go ahead and place it down right here. Our comparator, and our furnace that our comparator is getting its value from. Just like that. So I'll go ahead and load this up with 16 coal, which is enough to do a value of 2. Add that to our subtraction chain. All right, now we need to get the number 3 over here. So we'll go ahead and add some dust right here and simply add it in like this. And now we have that added to our subtraction chain. Let's load this furnace up with, let me look it up, 42 items. I'm sure 48 would work, but I'm just going to use 42. So 42 items in that furnace, and that should be enough for this to output a value of 4. Now our last one is going to be coming from here. We're going to route it up and over. There's our furnace. 1 over, route into there with a redstone repeater, some dust down here, and we just route along the top. Now let's go ahead and add in, for this we want to do a stack and a half. Oh, there we go, stack and a half of items in that one. And there we go, that should be it. Sorry if I went a little bit fast. Yeah, you're just gonna have to kind of pause the video maybe. And we can see now, when I activate, let's say 1, right? What that's gonna do is turn this torch off and cause this guy right here to be able to output into the subtraction line, which gets flipped and then outputted. So yeah, basically when you flip the lever, it allows the comparator that's coming out of the furnace to be added in to the signal line. And there you have it. A very simple, actually this is, I'm not sure if I've ever seen this before, a very simple 1-wide digital to analog converter. Or sorry, very simple 1-wide tileable or whatever. The levers are right next to each other is what I'm trying to say. I haven't really seen that before. So I'm pretty happy with that design. Yeah. So stay tuned for the next episode in this series. I'm going to be trying to show how this kind of stuff right here is going to be applicable to a survival situation. In fact, next episode in the series, I might focus solely on one application of this very digital to analog mechanism. So yeah, stay tuned. Thanks for watching and have a good day, guys.